Yes, sir. Thank you, sir. I think, sorry, gentlemen, seems to be some technical glitches. Maybe my chairman voice was not louder. Thank you, chairman. And now, see, I normally say that when we understand any topic, we need to know whom we are listening from. And for that, I now request our council member, Mr. Hema Prasad, to introduce the speaker to the audience, please.
Thank you, Cynthia, sir. So it's my pleasure to introduce today's speaker, Mr. Andrew Tagg. Mr. Tagg has worked in the metal casting industry for 46 years. Currently, he is a technical manager for John Winter since 2016. He is a global consultant for 15 years and as a technical director for major UK and US foundry groups. So today we got a very good experienced person. So now the floor is yours, sir. Thank you.
Thank you. First, thank you and good afternoon to everybody. Also,
Sir, voice is slow. Shekhar, are you able to hear?
No, sir,
Not voice is very, very low, sir.
very low. Okay. Hang on, let me do this. Let me take it. Okay, what the hell is it? I hate new Windows. I don't like new Windows at all. Where's the controls on Teams for audio? Mike, here we go. All right. Settings. All right, settings. Can you hear me now better?
Yes.
Can you hear me? You're clearing now,
Yes,
is it?
yes.
Okay.
Better. Yeah, much better.
Thank you. Okay.
Please go ahead.
Okay, firstly, I'd like to thank the Institute of Indian Foundrymen for inviting me to present at this chapter. I've been to the Chennai chapter several times, and it's a very warm and welcoming group of people, so thank you very much. So I'll start with presentation today, which is on Tagg, which are long-lasting die coatings, and they're designed to improve casting quality and productivity in the low pressure and gravity die casting fields. So this works. So next slide. I'm not an expert on Teams, but I'll try the next bit. Next slide. Okay, that's how you do it. Okay. Are you seeing the full screen there? Can you see the slide? Okay, everybody.
Yeah.
Yes, madam. Yes.
Yeah. Okay. So the the role of a die coating is one, to protect the die, so to ensure the die is protected from the molten aluminium. It also acts as an insulator to the die, so encouraging the right solidification, directional solidification or solidification patterns. It also forms the surface finish of the casting, and the die coating also results in, it can be designed to enhance metal flow. So the texture of the coating can be designed specifically to suit certain applications. Also, there's it can be some additional coatings could be used as lubricants, so it could be sprayed on top of a insulated coating, and also there's use of primer coatings like you would normally do on a building, where you put a primer on, then put a top coating on. So the whole application of die coatings have specific coatings for specific applications, and they play a significant role in the productivity. The life of the die coating obviously significantly affects productivity, because if the coating fails, then you have to take the die off the apparatus, and that's lost production. So die coatings, the range of die coatings suits most applications. I say they're designed to be sprayed directly onto die using a simple pneumatic spray gun. The type of spray guns I prefer are the one with the reservoir is sat above what they use when they are spraying cars. It's better with the reservoir above, because the person's hand will be manipulating the different angles, and it keeps a constant supply of coating to the gun. Right. Most coatings are sprayed between 330 and 100 microns. In the special cases of automotive wheels, four-wheelers produced by GDCs, the coatings can get up as thick as 800, and I'll talk about later. We supply the coatings are supplied in a thick liquid or a paste, and they're usually diluted down with deionized water or soft water. It's interesting. Only yesterday for the US, I got a question: would using not using deionized water and not using soft water cause a problem? And I said yes, it could. The minerals in the coating can react in hard water or non-deionized water, can react with the binder system and also will be leaving deposits on the dye. The coatings are non-hazardous, they're only organic and no VOCs, and they're supplied in between 8 and 25 kilogram pails. Slide. So here's a range of dye coatings. You see we have a whole range. I won't go down each one. I'll explain later each one's application, and I explain the different range of dye coatings for different applications. So let me start with the first one. Is our Tagg SXT, and this is a general smooth coating for general applications. Can be used on most dye, gravity dye or low pressure applications where the surface finish is very good, but they don't need specific surface finishes, such as the face of car wheels where you require really high surface. So it's a general long life dye coating, can be used on most applications. Here's an example in the UK. You see the coating there. There's the dye that's been sprayed and the coating itself. Minder Corsi is the example of a automotive wheel. This is a GDC application for a four-wheel car, a car wheel. You see the coatings applied there, which forms the internal. That part is what they call the top part of the dye, and that forms the internal part of the internal part of the casting there. Here's an example of a general application. This is a piston for motorcycles. Now, next range I want to talk about is car wheel applications. These are specific applications. Predominantly, most wheels are produced by LPDC. However, in India, there's a couple of plants, few plants that still produce them by GDC. So the application is completely different for both. So for automotive wheel application, we have two coatings for the wheel face, and these are titanium oxide based coatings. And this is what would be the bottom part of the die. It's a bit that forms a wheel. Has to be of a very high wheel face. Has to be of very high surface finish, because the appearance of the car wheels plays a major role in people choosing to purchase the car or not. Then we have Dytex ZR, which is a textured primer coating, which is sprayed on predominantly not the wheel face. It's sprayed on the side cores or the side inserts and the top die, and then we use the SXT as shown earlier on the top and side cores. The Dytex V is specifically for, in this case, for feeding, and is specifically for only GDC. Low pressure wheels do not require feedings, but GDC does. So in this case, this is a riser coating. So that's the four coating application that we would use for a GDC. And LPDC is different. Let me move on to that. So here's an example at minute course showing the application of TES. We got the customer got improved, reduced number of touch-ups, which is again loss production. So reduced the amount of loss production. And you can see on the left is the coating, 30 microns, and the surface finish there of the wheel. Another one, this is Maxion, this is LPDC, where this is the TZ. We use the TZ more for low pressure wheels, and it's a bottom die face again, and you'll see the pictures here. So there's the bottom die face, coated, and you can see the surface finish now. I enlarged that of the wheel, very high requirement for surface finish for these wheels. And the important bit was the, if I could go back one, was with our coating. So you will see the big thing was the touch-up time. Basically, the original process, they were touched up 6 times in 24 hours. With our, they were touched 4 times in 24 hours. So again, you see the coating is longer life. The coating is requires less touch-up, so therefore more production. And this is an example of steel strip wheels. Again, this is GDC, and it's RTS application. You see the example there of the smooth coating on the wheel face there. And this is a 4 coating system for GDC. This is showing the wheel and the bottom die part. And this explains the process. So on the top die, which is this part here, there's the primer coating. It's red, so it can show through when the other coating is wearing. Then on top of that, the SXT, and this is built up to 800 microns, which is a concealment coating. And the reason for that, I'll explain in a minute. But when you making wheels with gravity die casting, the metal enters, I'll show a picture of the die, the metal enters through the center into the bottom and goes up the sides. To stop shrinkage, you have to feed it from the top, and the resultant effect of that is you need a heavy insulated coating to enable directional solidification back to the risers. Also on this is why in this application we're adding a riser coating, which is there, and that it helps promote directional solidification. So you see, I've done the sort of like, if you imagine how it sits in the die, this schematic here showing that that's the bottom, that's the top, and these are the side cores. And these are the wheels. So what would happen, that this would have risers all around here, feeding into the bottom. So it's essential that the top die and the side cores have a significant amount of insulation. These coatings are thicker than you would use in any other die casting application. 800 microns.
Sir, presentation is not here.
You can't see?
Not seen, sir.
Oh.
Yeah.
So we are, no, we are able to see, sir.
Yeah.
Presentation.
Yeah, presentation we are able to see.
Oh, right. Okay. Right, sir. Here not seen, but anyhow, people is important. Okay, sir. You can continue, sir.
You can go out and come in again and see it, sir.
Okay, right.
Can everybody else see? Okay. Can everybody else see? Okay.
One second.
Yes, Andrew. Yes.
Yes,
Yeah,
sir,
okay.
visible.
Yep, okay. So is the next stage, we have a specific coating for motorcycle wheels, and the important thing with motorcycle wheels, unlike car wheels, is they have these thin little ribs in the coating. And I'll admit I made a mistake when I first came to India with die coatings. We don't in the UK, not many, and Europe, very few motorcycle wheels are made. So I had the guys at Forest, we worked together, and we supplied, the first trial was with a coating for car wheels, and it was disastrous because it was too smooth. So we had to develop a coating specifically for motorcycle wheels that give the right high surface finish, but enabled the metal flow to fill these very thin web areas. These castings are quite prone to no fill defects. So here's an example at Minda. It's a Supra, and it's about Bajaj I don't know, motorcycle wheel. You see that we've touched up 1 in 5 hours compared to touch up 1 in 2 hours. and you can see there's a top die, and there's again, this is gravity, and you can see the risers all the way around here. With big reduction in no-fill defects. He had a lot of no-fill in this center, this little center rib here and on these arms. So reduce the no-fill defects. This is a Rockman Hardiwar. Again, shots per hour increased because, and the number of times the touch-up was only 3 times in 24 hours compared to 6. Again, this was prone to no run defects on here, and again, we reduce those defects. And this is classic wheel. Again, there's a coating, and again, this had a certain problem in this area. The problem with gravity die casting compared to low pressure, if you imagine on a car wheel similar, is the metal's entering here, travel on here. So the metal entering this area is the coldest, and you have to promote directional lubrication back from the feeders to the center hub. So the insulating properties of the coating are very important. And I'll show later, we introduced Ditec V in these areas where the risers are, and that helps shrink its defects. So I'll move on to that later. Ditec M is a coating specifically designed. It's very textured for thin section castings. When you've got a thin section casting, you have to have, because the aluminium forms a strong meniscus, if you have too smooth a coating, 2 things happen. You can get entrapment of air, or you're not breaking the oxide film, so as the coating as the metal flows. So a smooth coating will impair the ability of the aluminium to flow. So for flat surfaces or surfaces of very thin section, you need a specific texture coating. So here's an example. You can see it's textured, this coating. This is a thin cover. See here, this is exceptionally thin, like 3 millimeters, where we reduce the rejects from, they call it cold shots in England, you guys call them no fill, from 8% to 1% because of the enhanced flow characteristics. This is manifold casting. You can see there's Ditec M, and there's a competitive product. Coating life increased from 3 to 6 shifts. Again, it's very textured, so there's no misrun defects. This is a low pressure rear hub for, I think, for a motorcycle. And you can see these very small, you can see the little ribs there in thin sections. Again, the rework was reduced by 50% and reduced the misrun stroke blows, or you call them no fills, by 5%. And this is again an example of a reduced misruns on a manifold casting. Ditec V, this is a very interesting coat we produce. It's a highly insulated coating. It can be used for the cavity and also applied thickly as a riser coating, so you can enhance solidification. So the example here, a large diesel oil pan in the US. This is very large. It's probably about 1.5 meters long. It's for a Caterpillar, and the die coat is applied. And it's what you call a tilt pour. So you might have seen these where you fill the chamber, it tilts up, and the metal runs down the chamber. You need a very highly insulated coating for that application, and that's what is used in this case here. I've put this on because it's quite an interesting. I've put the link on there. There's an article in Casting Source about a revolutionary marine engine, and the company called a Minnesota foundry called LaSalle in Minnesota developed the casting, a very intricate, very large, low pressure die casting, and they got the casting running, but they were a problem with porosity in certain numbers of bosses. They switched to our Ditec V, and it solved the problem. We can't show the casting because they're very how do you put it? They won't let you take pictures of it. However, if you want to look at that link, the link basically you can read the article in Casting Source. It explains how they designed the tooling and all that was involved to make this casting. They don't mention the Ditec V because they don't talk about die coatings, but we were asked in about 3 or 4 months ago. They did the trials and they resolved the shrinkage issues with that casting. So I thought I'd put that in so people understand the application for it. Here's another application that Spark Minder. These yokes, I think, for motorcycles, and they've got a 5% reduction in no fill defects by using Ditec. And this is where I talked about the motorcycle wheel. You can see we added the Ditec V as a riser coating, and we got a 7% reduction in shrinkage defects in the casting by, insulating the risers. If anybody's there from the sand foundry guys, it's akin to putting a sleeve in a sand bowl. Basically, it's an insulating material. And another example is a cylinder head for four-cylinder low pressure die casting process. Sorry, a motorcycle cylinder. Sorry. And again, we increase the flow of the metal in the casting. Now we'll talk about our primer coating. This is used as a primer to enable the top coating to adhere better. So as an example, in South Africa, it's some sort of light cover, and they use ZR first, and then they put the S on top of that. And this again, I explained the 4-wheel application. You've already seen that. We use it as a base coating there. And this was a casting where they used the Ditec ZR, and they put M on top. It has some thin sections, and that's been a significant reduction in shrinkage because of that process. The coating we're selling more and more in India is our Ditec D, which is a 2-part coating, and because it has exceptionally long life. One of the things I've noticed in India is the die temperatures run higher than Europe, and that's because the ambient temperature in the country, but the die temperature run higher, and it seems to me that having a very durable coat is important. So it's a 2-part coating, gives a smooth surface finish, but gives you a very long die life, coating life. So it's one in the US, which was a large pressure cooker that was selling at a massive increase during the pandemic for sterilization during the inoculation period. So they made loads of these. So you see there, it's a very large low pressure die casting. They got increased life of the touch up 3 to 4 hours compared to 6 times in 24 hours. And this is the cylinder head for a 4-wheeler cylinder head. Makes you improve operation by using our Ditec D. And finally, we found it was very useful because of in motorcycle cylinder heads. Let me explain why. What happens in the motorcycle cylinder, these fins, makes the casting difficult to remove from the die, and that tends to scuff the coating surface. And then what happens is they have to increase touch up in these areas. What actually happens is the thickness or the cavity gap to run the fin starts to reduce, and the resulting effect of that is to get an increase in no run defects. So when we ran, I'll go back to the results on the motorcycle, was we reduced the no fill defects because the touch up had gone from 3 hours to from 1 hour to 3 hours. So basically, we reduced the number of touch ups by a third, and the resulting effect that meant that the closing up of the fin area was reduced. So therefore, a reduction in no-fill defects. We have a lubricating coating called Tagg G, and basically this is applied, can be used, if it's on a cavity, you would spray it on top of the insulator coating to assist removal of the casting for parts that are difficult to remove from a die. And this was the cylinder head. You can see the graffiti coating on the cavity there. It can also be used, it can also be used as a paste for lubricating, metal inserts into the die. Like example, if you're making a hollow fork casting for a motorcycle fork, the steel core that goes in to form the internal shape is then coated in a lubricant, a solid lubricant like Tagg G, and that enables it to remove from the casting. So that's it. Any questions, anyone? People hear me? Hello?
Yes, sir.
Can you hear me, people?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Anyone has any questions?
Yeah, this is Venkat from Synergies.
Yeah?
Can I ask your mail ID so that I can communicate you regarding some die codes which I need?
For Chennai? Yeah, you have to, right, you can send an email to me or to the forest representative. Do you have the forest representative there?
No.
Yes, Andrew.
Yeah.
Hello, Mr. Venkateshwar.
Yeah. Tell me.
Kanika this side from Forest Polymer.
Yeah.
So you can share your queries on mdoffice@forestpolymers.in.
MD at the rate of
mdoffice
MD office at the rate of
forestpolymers.in.
Forest Polymers. Okay. Yeah.
Yes, sir.
Thank you.
Thank you.
Very quiet. Usually you guys are very talkative.
So any questions for Mr. Andrew? Oh, there's a question actually in the chat box, Mr. Andrew.
Oh, chat box. I can see it. Let me bring up chat box. Where's I hate Teams chat. Here we go. Yes. Can we reduce problems in GCL wheel component through coating? Sir, Chandan, can you remember yes, the answer is correct. Yes, you can. The coating plays a role in one is porosity. In GDC, is this car wheels or motorcycle wheels? Is this an automotive wheel or motorcycle wheel? I'll cover both anyway. If it's a motorcycle wheel, then yes, you can reduce porosity by using our insulated Tagg V on the risers. By adding that to the risers, that will help to create directional slivification back to your risers. If it again on if it's a GDC car wheel or four-wheeler, the same, adding the Tagg V to the area of the riser will assist feeding. Also, getting the right coating thickness. It's hard to describe it without actually drawing it, but you say you've got 5 or 6 risers around the top of the casting. It's beneficial to create a coating thickness that varies around the circumference. So you effectively trying to create directional slivification back to the riser. Do you understand what I'm saying? And that would be a way of doing it. But on the first thing I would look at is using our Tagg V on the risers as a paste to create better insulation of the risers. Does that help?
So if we don't have any questions, actually, I think already the mail ID has been shared in the chat box, so people can write to Mr. Andrew directly to clarify your queries. So,
So that's one. Any other questions verbally? Or
I think there's no more questions, Mr. Andrew.
okay. Well,
So,
I'd like to thank
yeah.
I'd like to thank everybody for listening. Thank you very much.
Yeah, I'll wind up with the vote of thanks. So, on behalf of IIF Chennai Chapter, we want to express our sincere thanks to everyone who participated in our today's webinar. I thank Mr. Andrew for sharing your knowledge and insights in the field of die coatings with us. Your expertise is invaluable. Thank you for being part of today's learning. Thank you everyone for making this webinar a success. Thank you, Mr. Andrew, once again.
I'll see you all in Bangalore in 1st of February.
Yeah,
Bangalore IFX.
2, 3, 4. Yep.
Yeah, IFX. Goodbye, everybody, and have a nice day. Have a nice afternoon.
Thank you very much. Thank you all.
Thank you.
Thank you. Bye.